On this channel, we provide useful programming information with practical code examples. This time, it is about Python's copy module. Focusing on the differences between shallow and deep copies, we provide a clear explanation, from the basic mechanisms of object duplication to applications in custom classes, along with practical examples. Enabling subtitles will make the code descriptions easier to understand. Python's copy module is the standard module for handling object duplication, copying. The goal is to understand the difference between shallow and deep copies and to be able to control copying behavior for custom objects. Here we illustrate the behavior of shallow copies for mutable objects such as lists and dictionaries. A shallow copy duplicates only the top-level object and shares the references inside. In this code, the top-level list is duplicated, but the inner sublists are shared by reference, so shallow 1 append 99 is also reflected in original. This is a typical behavior of a shallow copy. A deep copy recursively duplicates the object and all of its internal reference, producing an independent object. Use it when you want to safely duplicate complex nested structures. In this example, changes to deep do not affect original. Deep copy copies the entire object graph, yielding an independent replica. Which copy to use should be determined by the object's structure and your purpose. If you do not want changes to internal mutable elements to affect the original object, deep copy is appropriate. This is because it recursively duplicates the entire object, creating a completely independent copy. On the other hand, if duplicating only the top-level object is sufficient and you value speed and memory efficiency, copy, a shallow copy, is more suitable. Immutable objects, e.g., int, str, and tuples whose contents are immutable, usually do not need to be copied. Copy may return the same object when appropriate. Since copying immutable objects provides little efficiency benefit, the same object may be reused. This is rarely something you need to worry about in application design. If the default copying is not what you expect for your class, you can provide your own copy logic. If you define copy and deep copy, and copy, deep copy will use them. By implementing copy and deep copy, you can flexibly control class-specific copying behavior. For example, you can handle cases where certain attributes should refer to, share, the same object, while other attributes should be duplicated as entirely new objects. The memo argument passed to deep copy is a dictionary that records objects already processed during recursive copying and prevents infinite loops caused by circular references. In this code, the variable shallow_copy is created via a shallow copy, so only the top level of the object is duplicated, and the objects it references internally, in this case, the children list, are shared with the original root_node. As a result, when you add a new node to shallow_copy, the shared children list is updated and the change is reflected in the contents of root_node as well. On the other hand, the variable deep_copy is created via a deep copy, so the internal structure is recursively duplicated, producing a tree completely independent of root_node. Therefore, even if you add a new node to deep_copy, it does not affect root_node. When a complex object graph references itself, cyclic references, deep copy, uses a memo dictionary to track objects already copied and prevent infinite loops. Internally, deep copy uses memo to refer to objects already duplicated, enabling safe copying even in the presence of cycles. You need a similar mechanism when performing recursion manually. If you want to register special copying behavior in coordination with libraries, you can use the standard copyreg module to register how objects are reconstructed. This is useful for complex objects and C extension types. Using copyreg, you can provide reconstruction rules that affect both pickle and deep copy. It's an advanced API, and in most cases, deep copy is sufficient. There are several important points to ensure correct behavior when using the copy module. Below we explain common pitfalls you may encounter in development and how to avoid them. Performance. Deep copy can consume significant memory and CPU, so consider carefully whether it's necessary. Handling elements you want to share. If you want some attributes, such as large caches, to remain shared, intentionally avoid copying their references inside deep copy. Immutable internal state. If you hold immutable data internally, copying may be unnecessary. Threads and external resources. Resources that cannot be copied, such as sockets and file handles, are either meaningless to copy or will cause errors, so you must avoid copying them by design. When updating a complex configuration object, this example uses deep copy to protect the original settings. Using deep copy, you can safely create derived configurations without risking damage to the default settings. This is especially useful for nested mutable structures such as configurations. To use the copy module safely and effectively, it's important to keep the following practical guidelines in mind. Choose between shallow and deep copies based on whether changes will occur and their scope. Implement copy and deep copy in custom classes to achieve the expected behavior. Because deep copies are costly, reduce the need for copying through design when possible. Consider immutability and explicit clone methods, among other techniques. When dealing with cyclic references, either leverage deep copy or provide a memo-like mechanism manually. Designed so that external resources such as file handles and threads are not copied. The copy module is the standard tool for object duplication in Python. By correctly understanding the differences between shallow and deep copies and implementing custom copying behavior when needed, you can perform duplication safely and predictably. By clarifying at the design stage whether copying is truly necessary and what should be shared, you can avoid unnecessary bugs and performance issues. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. If you found this video helpful, I would appreciate your support by subscribing to the channel.